All right, so we're continuing with the chain rule, section 2.4, and this video I'll go over some trigonometry examples involving the chain rule. Now in the integration table or table of derivatives that's in the front of the textbook, you'll see something where they have the letter u, and for instance, if you took the derivative of, it'll have like sine of u, and that's equal to cosine u times u prime. All right, this is the chain rule, and the chain rule involving where u is a function of x. And that's where all these different trig functions in the front, or pretty much all of the derivatives, have this letter u. It's assuming u is a function of x. All right, now I'll just go ahead and write which one's going to apply for each problem. So for number 35, so this is chain rule. Trig function. So u is a function of x, your outside function in this case is sine, the inside function is u. Now for number 35, our outside function is cosine. All right, and so we're going to use the derivative involving cosine, and its derivative, cosine of u. Well, from previous section, the derivative of cosine is negative sine, so it's going to be negative sine of u times the derivative of the inside, and the inside function in this case is 4x. So for our example, u is going to be 4x. That's our inside function. U prime is going to be 4, because the derivative of 4x is 4 times 1, which is 4. So you could be extra thorough about it and write it as y equals and then cosine u. So, and then I take the derivative. So y prime, that's going to equal derivative of the outside function is cosine. Derivative of cosine is negative sine. So it'd be negative sine, and then u times u prime. Sorry about that. All right, and so I have negative sine of u times u prime, and I just substitute, well, u is 4x and u prime is 4. So it's going to be y prime is equal to negative sine of 4x times 4, which is just negative 4 sine of 4x. That's pretty much it. That's going to be the answer. All right, so next one involves tangent. So from the list of derivative tables, like you did the chain rule to tangent, the rule is if you have tangent of u, derivative of tangent secant squared, so this turns into secant squared of u times u prime. And so for our question, I'm going to let u be 3x. That's my inside function. That's what I'm applying with tangent. Tangent's my outside function. U prime is going to be 3, since the derivative of 3x is 3. 3 times 1. So g prime of x, so it's going to be, and I factor the 5 in front and worry about the tangent piece. So focusing on that, tangent becomes secant squared of u, and then u is 3x. And then all of that times u prime, which is 3. All right, so I just do 3 times 5 to get 15. So g prime of x is equal to 15 secant squared 3x. All right, so that's how I do that one. Now this next one is going to be pretty involved, this next problem, and it's number 41. All right, so there's multiple ways you can go about doing the problem. I'm going to show a different way than in the notes that are on Blackboard. So I'm going to make a comment note. In the worked out solutions on Blackboard, I use the product rule. Really, it's a combination of product rule and chain rule. So I use a combination of product rule and chain rule. And the reason why I would use product rule is because I have sine of 2x times cosine of 2x. So I have two trig functions being multiplied together. So it's a product. And then that's why I use the product rule. And the chain rule comes into play because for the 2x part, instead of it being sine x cosine x, you have 2 times x. So your inside function for each of these is 2 times x. So instead of doing it this way, because this involves a lot of steps, instead I'm going to try to use a trig identity. All right, and the trig identity is going to be the double angle identity for sine. So on Blackboard, I do have a document, and that document has all of the trig identities. So the double angle identity for sine is sine of 2 theta is equal to 2 times sine of theta cosine theta. Now our problem has sine of 2x cosine 2x. So we have sine of 2x cosine 2x. So I'm going to do some algebra manipulation. And for that manipulation, so it almost has this structure of 2 sine theta cosine theta, but in this case, theta is 2x, and notice I'm missing a 2 in front of it. So you can rewrite the double angle identity for sine by dividing both sides by 2, which will give you 1/2 sine of 2 theta is equal to sine theta cosine theta. So for our problem, and again, theta is, we're using 2x for theta. So we have the right-hand side matching up. So this is going to equal 1/2, and then sine of 2 times theta is going to be 2 times 2x. And if 2x is theta, so 2 times that's going to be 4. So this would be 1/2 sine of 4x. All right, so if theta is 2 times x, that means 2 times theta. I multiply both sides by 2. Is 2 times 2x. So 2 theta is 4x in our problem. Now what this does is I rewrote the problem. Instead of being a product of 2 trig functions, I've narrowed it down to just one trig function involving sine. So the original problem was h of x equal to sine 2x cosine 2x. Now I'm going to rewrite it. So h of x is now equal to 1/2 sine of 4x. All right, so now it's easier to find this derivative. It avoids having to use the product rule. All right, so I only need to apply the chain rule for this and the derivative of sine. So I'm only going to apply chain rule involving sine. So derivative of sine of u is cosine of u times u prime. In this case, u is 4x. All right, so that's our inside function. So u prime is 4, since it's 4 times 1. So h prime of x, factor out the 1/2, so it'd be 1/2, and then times cosine of 4x, since u is 4x, and then times u prime. Well, u prime is 4, so it'd be times 4. All right, then I just do 4 times 1/2 to get 2. So our answer is going to be 2 cosine of 4x. All right, this is the quickest way to do the problem, in my opinion. So again, in the worked out solutions on Blackboard, I use the product rule by letting the product because it's sine and cosine. And I end up using a combination of product rule and chain rule because of the 2x to be the inside functions for each trig function. And then I also use a trig identity in simplifying after I apply the product rule. So it's a lot more steps. So I'm still using a trig identity either route. It's just for this one, I recognized that it had the double angle identity is 2 sine theta cosine theta. Our problem has sine of 2x cosine 2x. It's just really missing the 2. And then I can line up 2x with theta. So based on this relationship, if I divide both sides by 2, that means 1/2 sine theta, or 1/2 sine of 2 theta is equal to sine theta cosine theta. So that way it matches up with what we have. And then I just have to do 1/2 sine of 2 times theta, which again, theta is 2x. So I multiply 2x by 2 to get 4x. So that reduces the problem into one trig function. And I just applied that chain rule with sine. and then that gives me my answer. All right, so that's where I'll stop it with this video, and I'll go into more complicated examples in the next video.